Welcome to the SAP Business AI series from Aditheos. I'm going to walk you through 9 episodes that take you from the absolute fundamentals of AI, what it is and how it works, all the way through to building production AI on SAP BTP. This first episode is about AI fundamentals. Before you can make sense of SAP Joule, the Generative AI Hub, or agentic workflows, you need a solid grounding in what artificial intelligence actually is. Not the marketing version, the practical understanding that helps you ask better questions and make smarter decisions. Let's get into it. In this episode, we're covering 5 things. First, we'll define what AI actually is. Then we'll look at the 3 tiers of AI capability, so you can separate what's real from what's still theoretical. From there, we'll walk through the AI technology stack, the 6 layers that power everything from SAP Joule to the Generative AI Hub. We'll also look at why data quality is the single biggest factor in whether enterprise AI succeeds or fails. And we'll close by tying it all together, how these layers fit as a connected ecosystem. Let's start with the definition. Artificial intelligence is a branch of computer science focused on building systems that can perform tasks that normally require human intelligence. Things like understanding language, recognizing patterns, and making decisions with incomplete information. Here's the most important distinction to understand. Traditional software follows rules that a programmer explicitly writes. AI learns its own rules from data. You feed it enough examples and it figures out the patterns on its own. Why does this matter in an enterprise context? When SAP embeds AI into invoice matching or demand forecasting, it's not running a scripted process with pre-programmed outcomes. It's running a system that has learned from millions of similar transactions, and it continuously refines its performance as new data arrives. That's a fundamentally different kind of software. Now, AI professionals and vendors often speak very loosely about what AI can do. So let's give you a precise framework. On the left, narrow AI. This is where we are today. Every AI system you actually interact with, SAP Joule, voice assistants, fraud detection, recommendation engines, is narrow AI. It does one thing exceptionally well. And within that domain, it can outperform humans consistently at scale. A demand forecasting model doesn't get distracted, doesn't have bad days, and processes thousands of SQs in the time a human analyst reviews 10. That focused, tireless performance is what creates enterprise value. On the right, general AI and super AI. General AI means systems that can apply intelligence across any domain, the way a human accountant can also write a memo, coach a colleague, and evaluate a supplier contract. We don't have this today. The most capable LLMs appear general because they span many domains, but they have no real understanding. They're pattern matching at extraordinary scale. True general AI remains an active research challenge with no clear timeline. And super AI, machines exceeding human intelligence across every dimension, is a conceptual direction that shapes ethics debates, not something you need to factor into your implementation decisions right now. Modern enterprise AI is not a single technology. It's a stack of interconnected disciplines, each one building on the one below. Let me walk you through the 6 layers. At the foundation is machine learning. ML gives systems the ability to learn from data and improve over time without being explicitly reprogrammed. SAP uses ML extensively for invoice matching, anomaly detection, customer sentiment analysis, and demand forecasting. Above that is deep learning, a specialized subset of ML that uses neural networks loosely inspired by the human brain. Deep learning is what made modern speech recognition, image classification, and document processing reliable enough for enterprise deployment. Natural language processing sits on top of that. NLP is the layer that gives machines the ability to read, interpret, and generate human language. Without it, you couldn't ask Joule a question in plain English and get a meaningful answer. Generative AI is the technology that produces new content, not just analyzing existing data, but constructing something new. A product description, a code suggestion, a document summary. This is what makes SAP Joule and the Generative AI Hub fundamentally different from a search engine or a rule-based assistant. Large language models are the engines behind generative AI for language. They're built on transformer architecture, trained on billions of parameters, and they understand context, intent, and the relationships between ideas across an entire document. And foundation models are large AI systems trained on massive, diverse datasets that can handle a wide range of tasks without task-specific training. GPT-4, Claude, Gemini, these are foundation models. SAP's Generative AI Hub gives you access to multiple foundation models, so you can choose the right one for each use case. Here's the thing that gets overlooked more than anything else in enterprise AI discussions: data quality. AI doesn't possess inherent knowledge. It reflects what it was trained on. An AI system trained on incomplete, inconsistent, or biased data will produce incomplete, inconsistent, or biased outputs at scale and at speed. For enterprise AI to deliver genuine value, your underlying data needs to be organized and accessible, accurate and current, complete enough that the AI isn't filling gaps with guesswork, and governed with clear ownership and privacy controls. This is why SAP's investment in the SAP Business Data Cloud and the SAP Knowledge Graph is so strategically important. They're not just data management tools, they're the foundation that makes enterprise AI trustworthy and actionable, rather than impressive but unreliable. So how do all these layers fit together? Think of them as nested rather than separate. AI is the broadest field. Machine learning sits inside AI. Deep learning sits inside ML. Foundation models sit inside deep learning. LLMs are foundation models specialized for language. Generative AI refers to models, often LLMs, that create new content, and RAG, Retrieval Augmented Generation, is a technique layered on top of generative AI that grounds outputs in real current business data. When you hear that SAP Joule is powered by LLMs via the Generative AI Hub with RAG grounding, every part of that sentence maps to one of these layers. Understanding the stack means you can evaluate those claims, spot the gaps, and ask the questions that matter. Let's close with the key takeaways from this episode. AI learns rules from data. It's not following explicitly programmed instructions. All commercial AI today is narrow AI, highly capable within defined domains, but not generalizable across them. The technology stack runs from machine learning through to generative AI and RAG, each layer building on the one below. Data quality isn't a prerequisite for AI, it is AI. Bad data means bad outputs at scale. And understanding these layers is what lets you evaluate vendor claims and make better implementation decisions. In the next episode, we're going deeper on the core technologies, how LLMs actually work, what RAG solves and how the Model Context Protocol enables AI agents to interact with the outside world. Subscribe so you don't miss it, and visit aditheos.com for more SAP and AI content. I'll see you in episode 2.